Sometimes, like with the BF3 molecule, there are multiple ways we can draw the structure. We will use formal charge to decide which is the most appropriate drawing. Formal charge is the charge an atom would have if we were to break the bonds in half, and each atom in the bond would keep half of the electrons from the bond. To calculate formal charge, we will take the number of valence electrons and subtract the number of associated electrons for each atom in a molecule. You already know how to find the valence electrons. That will just be the group number of the atom. The associated electrons are all the ones that will belong to a particular atom for formal charge. The atom gets all of its lone pair electrons because they are just on that atom alone. The atom also gets half of the electrons from the bond. If it's a single bond, it would give each of the two atoms 1 electron. If it's a double bond, it would give each of the atoms 2 electrons. If it's a triple bond, it would give each of the atoms 3 electrons. Basically, for each line in the bond, each atom gets 1 electron. Therefore, it is easiest to find associated electrons by counting dots and dashes around each atom. Each dot is 1, and each dash is 1. This is different from assigning electrons for the octet rule. For the octet rule, all the electrons in the bond belong to both atoms. For associated electrons for formal charge, each atom only gets half the electrons in the bond. Here's an example. In ozone, each oxygen is going to end up with a different formal charge. The oxygen on the left has 6 valence electrons because oxygen is in group 6A. It has 4 dots and 2 dashes around it, so it has 6 associated electrons. We do valence minus associated and get 0 for the formal charge on the left oxygen. The middle oxygen also has 6 valence electrons because it is also in group 6A. It has 2 dots and 3 dashes, making 5 associated electrons. 6 minus 5 gives a +1 formal charge. It is really important to do valence minus associated, not the other way around, or you will end up with the wrong sign on your charge. The right oxygen also is in 6A, so it has 6 valence electrons. It has 6 dots and 1 dash, making 7 associated electrons. 6 minus 7 gives a -1 formal charge. The sum of the formal charges should add up to the charge on the molecule or ion. For a neutral molecule like ozone, the formal charges should add up to 0. In this case, 0 plus 1 and minus 1 add up to 0. For an ion like nitrite, the formal charges should add up to the charge on the ion. In this case, 0, 0, and minus 1 add up to -1. What is the formal charge on nitrogen in the nitrate ion? You'll need to draw the correct Lewis structure first before calculating formal charge on the nitrogen. Is it A, -1, B, 0, C, +1, or D, +2? The correct answer is C, +1. Please look at the poll question key to see an explanation for how to find the answer, including a picture of the nitrate ion. It ends up with a double bond to one of the oxygens and a single bond to 2 of the oxygens. Nitrogen has 5 valence electrons since it is in group 5A. It has 0 dots and 4 dashes, making 4 associated electrons. 5 minus 4 equals +1 for its formal charge. As a challenge, you could try finding the formal charges of the oxygens as well, and double-checking that the formal charges all add up to -1. We aren't just finding formal charge for the fun of it, although I think it's pretty fun. We're doing it because we want to choose the best structure from several good options. We would still want to make sure the structures we are choosing from all use the correct number of valence electrons and all generally follow the octet rule, with our octet rule exceptions in mind. As we are picking structures, we want to minimize formal charges. If we can get the formal charges to all be 0, that is going to be the best option. If that is not possible, we want the smallest amount of charge on each atom. +1 or -1 are going to be better than +2 or -2. When two atoms are next to each other and have a non-zero charge, it is better if those charges are opposite. For example, in ozone, we saw one oxygen atom with a +1 formal charge and the oxygen next to it with a -1 formal charge. That would be better than having them both be plus or both be minus. Finally, if there are structures with the similar formal charges, we want the more negative charge to be on the more electronegative atom. If the atom wants electrons more, electrons will spend more of their time near it, and it will be slightly negative. In the top example on this slide, we have 3 options for the CO2 molecule. The one on the left has the lowest formal charges, so we choose that one. Notice that the option on the right has an oxygen in the middle instead of carbon, giving it the largest formal charges. This is why we put the least electronegative atom in the center of our Lewis structures. In the bottom example on this slide, we can rule out the left option because it has a +2. We can rule out the second option because it has larger charges than the right 2 options. Choosing between the right 2 options is trickier. They both have 3 zeros and a -1. We must choose the one where the negative charge is on the more electronegative atom. That is option 3. Oxygen is closer to the upper right of the periodic table, so it is more electronegative. Notice that option 3 gives bromine more than an octet. Option 1, where it only had 8, actually was the worst of the bunch. You will always want to check formal charges when the central atom is in period 3 or below, so that you can figure out how many double or triple bonds it should have. Here is a summary of some of the trickier things we have talked about related to making double or triple bonds. We never make them when the central atom is in group 2A or 3A. We always make them in step number 5 if the central atom is not in 2A or 3A and still needs electrons to complete its octet. Now you've just learned that we also make double or triple bonds if demanded by formal charges. If the central atom is in period 3 or below, you're especially going to want to check formal charges to see if it needs more bonds in order to lower formal charges. Keep checking your answers to make sure they have the correct number of valence electrons and that all atoms that need to obey the octet rule do so. Only the central atom can have more than an octet, and that central atom must be in the 3rd row of the periodic table or below. The terminal atoms never have more than an octet. Choose the best structure from the following based on formal charge. Is it A, SCN-1 with 2 double bonds, B, SNC-1 with 2 double bonds, C, SCN-1 with a single bond, then a triple bond, or D, SCN-1 with a triple bond, then a single bond? The electronegativities of sulfur, carbon, and nitrogen are 2.5, 2.5, and 3.0, respectively. The correct answer is A, SCN-1 with 2 double bonds. To answer this problem, we have to assign formal charges to each of the 3 atoms in each of the 4 answer choices. Please see the poll question key for all of the formal charges. In A, the formal charge on sulfur is 0, the formal charge on carbon is 0, and the formal charge on nitrogen is -1. In C, the formal charge on sulfur is -1, carbon is 0, and nitrogen is 0. They have the same distribution of charges, 0, 0, and -1. We need to use electronegativities to tell which atom should have the -1 charge. Since nitrogen is more electronegative, it should have the -1 charge, making A the correct answer.